3.1 Chain rule, a very fundamental skill you need to know how to do. So the first thing you want to recap is composite functions, is when we have a function within a function. So here, like f of g of x. Let's look at these examples. Sine of x squared. We're used to seeing something like sine x, but this is x squared. You see the outside function is f of x is equal to sine x, but on the inside it's an x squared, not an x. So it's g of x is equal to x squared. Because if you do f of g of x, you plug in the x squared into the f of x and you get sine of x squared, what this is here. So here f of x is equal to the outside, the square root of x. And then on the inside, it's natural log of x. This one here, this is going to be a larger one. There's a function within a function within a function. F of g of h of x. The outermost function is cosine of x. The secondary inner function is sine of x, because you see the sine here. And then sine of x, it's a sine of 5x. So h of x is equal to 5x. So to find the derivative of a composite function, it's f prime of g of x multiplied by g prime of x. We're going to do some examples right now. If you look at this first one here, find the derivative. So this is x squared minus 5 to the fourth power. So the outer function is the x to the 4. So what we can do here is take the derivative as normal with the power rule, like bring the 4 down. 4 times x squared minus 5, and then 4 minus 1 cubed. And then you multiply by the derivative of the inside here. Derivative of x squared minus 5 is just 2x. And then you can simplify it as 4 times 2x is 8x multiplied by x squared minus 5 cubed. That's your answer for the first one. The second one here, again, this is square root of 4x minus 3. So you can think about this as 4x minus 3 to the 1/2 power because it's a square root. So here, same thing with the power rule here. Bring the 1/2 down as normal. Pretend this was like a normal x. 1/2 times 4x minus 3. One sec. Sorry. So this is a 1/2 times 4x minus 3 to the negative 1/2. And then we multiply by the derivative of the inside, which is 4. And that's just equal to 1/2 times 4 is 2 on the top. And then it's a 4x minus 3 to the negative 1/2. So it's a root 4x minus 3 on the bottom. This one here. You can rewrite this function right here as the sine and square root of 5x is the same as sine of 5x squared. So you can now apply the power rule and the chain rule. H prime of x is equal to, bring the 2 down, 2 times, and then you just leave the sine of 5x there. And then 2 minus 1 is just 1. We don't have to write that. And then you have to multiply by the derivative of the inside here. And the derivative of the inside there, you have to use the chain rule again. It will be, well, cosine of 5x, because the derivative of sine x is cosine. Leave the 5x, and then you have to multiply by the derivative of the inside piece here. And then when you simplify this all, h prime of x is equal to 2 times 5 is 10, sine of 5x times cosine of 5x. All right, here. if you can see here, the outside function's an ln of x, and the inside, well, it's an x cubed, not an x. So if you recall, the derivative of ln x is just 1 over x. So you can take the derivative of this as normal, so 1 over x cubed, but then you have to multiply by the derivative of the inside, which is 3x squared. And then when you simplify that, you get a 3 over x. Here's another way you can do this same problem. If you recall your natural log rules, you can rewrite the y. Anytime you have an exponent with a natural log, you can bring it to the front. This power here will go here. We're just rewriting. We haven't taken the derivative. So if you want to find the derivative now, it's just 3 multiplied by the derivative of ln x, which is 1 over x, and you get the same answer. All right, this problem right here is a lot. We're not going to fully simplify this, but if you want to find the derivative, again, this looks really ugly, right? But think about this as like an x cubed, like the outer function's like an x cubed, but then instead of an x, it's this nasty fraction here. So we can do the power rule as normal. The derivative of like x cubed is 3x squared, right? So bring the 3 down, leave the inside piece, squared, and then we have to multiply by the derivative of the inside. So to find the derivative of this fraction here, we have to use the quotient rule. Low d high minus high d low over low low. Let's just do this all right here. So low d high is, the low is 2t minus 5. The derivative of the high is derivative of t squared plus 1 is 2t. Minus high d low, so minus t squared plus 1 multiplied by the derivative of the bottom, which is 2. And then over low low, 2t minus 5 squared. Well, let's just leave it like this. I'm nice, so we don't have to simplify all this. So next page here. If g of x is equal to 2x times root 1 minus x, find g prime of negative 3. So before we can find g prime of negative 3, let's first find g prime of x. G prime of x is equal to, well, here you have to utilize the product rule. You see it's a 2x times this. This is a product rule and a chain rule. But first you can take the derivative of the 2x, which is a 2, and you just leave the other. And then you have to add 2x times the derivative of 1 minus x. So 1 minus x can be rewritten as 1 minus x to the 1/2 power. So if you want to find the derivative, we can just bring the 1/2 there, down, times 1 minus x to the negative 1/2. And then we have to multiply by the derivative of the inside piece, which is a negative 1. So here, to find g prime of negative 3, well, another thing, we can simplify this a bit. Let's rewrite this as 2 root 1 minus x. You see how the 2 and 2 cancel out and it becomes a minus. So it becomes a minus 1 over, because it's a 1 minus x to the negative 1/2. It's a square root of 1 minus x on the bottom here. So right here, we are going to, sorry, one sec, I made a mistake here. 2 times 2, I forgot, oh, there's an x up here. Should be an x up there, because the 2 and the 2 cancel out. It's a negative x on top and the square root of 1 minus x on the bottom. All right, good. So g prime of negative 3 is just equal to, you plug this all in. 2 square root of 1 minus negative 3 is positive 4. So 2 times root 4. Minus negative 3, so I'll just do plus positive 3 over square root of 4 again. This is just equal to 2 times, well, root 4 is 2, times 2 is 4, plus 3 over root 4 is 3 over 2, and that would get you, well, that's 2 over 8 plus 3 over 2. You get 11 over 2 as your final answer. Again, there's a lot of steps to these. If you have confusion with how we got a step here, please, please, please let your teacher know. Going down with these table ones before you get to do some practice. So f of x is equal to g of x squared. And they want us to find f prime of 4 for each of these functions. So first we got to find f prime of x. Chain rule problem here. Bring the 2 down, 2 of g of x to the first power multiplied by g prime of x. So f prime of 4 is equal to 2 times g of 4. G of 4 is 3, multiplied by g prime of 4, which is negative 2. And that is 2 times 3, which is 6. 6 times negative 2 is negative 12. This one here. Again, you can rewrite this as, we're not finding the derivative yet, I just like to rewrite this as h of x to the 1/2 power. So now when I find the derivative, it's 1/2 times h of x to the negative 1/2 multiplied by h prime of x. If you're going to simplify it a bit, it'll be 1 over 2 square root of h of x multiplied by h prime of x. So now, f prime of 4, just plug all these in. That's 1 over 2 times the square root of h of 4, which is 9, multiplied by h prime of 4, which is 5. That's 1 over 6, because square root of 9 is 3 times 2, that's 6, so 1 over 6 times 5. F prime of 4 is just 5 over 6 in this problem right here. Last one right here. F prime of x is equal to h prime of g of x times g prime of x. So f prime of 4 is equal to h prime of, well, g of 4 is equal to 3 times g prime of 4, which is negative 2. H prime of 3 is equal to, see, the g of 4 is 3, and now we got to do h prime of 3. H prime of 3 is negative 3 multiplied by negative 2, which gives us a positive 6 as our final answer. You can go ahead and start the practice questions.